Next section we're going to look at is starting to get into the actual fuel feed, getting fuel to our various users. Okay, what are the users of fuel? What do we use fuel for on a transport aircraft? The engine's the big one. There's usually one other item. The APU. That's it. Engines or APU pretty much are the only fuel users. Okay? What's that? We have plenty of hot air from the engine, so we don't need like a fuel-fired heater or anything like that. So to get fuel to move around, we have two basic pumps we're going to use. The first one is electric pumps, and these can be AC or DC. This happens to be an AC auxiliary pump, but you can also have versions of these that are DC, typically used to send fuel to the APU during initial engine startup. It'll run on the battery. You have one DC pump to get fuel to the APU. Once the APU is running, you have AC power available from the APU generator, then you can use that to run all the AC pumps that send fuel to the engines, so now you can start your engines. But modern aircraft use a cartridge style pump. And most aircraft you're going to see operating in your careers are probably going to use these if they use an electric pump. And many aircraft use a combination of electric as well as the one we'll look at in a second, which is a motive flow. But what you have is this right here is not the pump. This is a canister for it. And we're looking at, on the left, this is the bottom. If we were to take this and look at the very bottom of it, it would bolt into the wing with these different things. And you can see there's an electrical plug on the pump. So the fitting is this outer ring right here. The actual pump is in here is this kind of inner ring. So you can see there's like an outer silver ring below, and then you've got the inner greenish type ring above. That's the pump itself. Okay? So the nice part about these is the way they work is down here you have this screen is the inlet for the pump. So it's going to suck fuel in here. And then the pump is going to push fuel out the top, out this upper opening here. Now this upper opening would have a tube or hose or whatever hooked to it going to your fuel system. Okay. So the bottom part's bolted into the wing. The upper part here is hooked to that. And inside of here, what we can't see is a check valve. So what these allow us to do, modern aircraft, is be able to change a failed pump without having to defuel the entire wing or the entire tank. Older aircraft, this was not a cartridge and fitting style, it was just pump. And so if you had to change the pump, you had to defuel the tank first before you could do it. So what happens here then is on the right, you have the actual pump itself. Okay, they call it canister, and then the cartridge is the pump itself. So here is the opening that aligns with this screen right here, and you can see just barely a impeller in there. These are an impeller style pump or a centrifugal pump. So it pulls fuel into the middle. When it spins, it pushes out. It looks like a centrifugal compressor that a turbine engine uses. It pushes the fuel up and out. Then it travels up to the top, and then it's able to come out through this fitting right here and be pumped into the fuel system. So for your purposes, to change one of these, it's really slick. We just disconnect the cannon plug that supplies power. It has a little plug right here, and then you have a handle right here. And so what you do is the first thing you do is disconnect the cannon plug. Actually, the first thing you do is pull the circuit breaker. Then you disconnect the cannon plug. Then you take this handle, you drop it down, and you turn the pump a little bit. Okay? But you don't pull it out right away. When you turn it, that closes the check valves inside of here. So at that point, then you can remove this little plug that's on the pump canister, the actual pump itself. That will drain the little bit of fuel that's inside of here, because remember, we've turned it to close off any of these openings. We drain the fuel out of this little canister. It's not even, maybe a couple cups of fuel. And then once it's drained, you can turn it, usually you can pull down, turn it a little further, and pull it out the rest of the way. And then you grab your new one, you put it in, you turn it. Let me think. You turn it, and you pull down, that closes the valve, you take off the little plug, and then once it's drained, you turn it the rest of the way and pull it out. So the new one you put in, you turn, no, you put in, you turn, you push it up and turn. There we go. Yeah, there's two pushes, two turns. Okay. But, and obviously your procedure will be specific to the pump, but the nice part is it makes it easy to change it without having to defuel the aircraft. It's a fairly quick process, whereas before defueling and changing pumps was a very involved process. The other thing is you can see this style, the wiring is on the outside of the wing. The old pumps, some of them were just submersible. You actually had wiring inside the wing you had to deal with. Now, it was usually in tubes that were connected to the, so you'd have to open up like tubes. They're almost like the steel tubes with the B-nut. You pull that back, and then you can undo the wiring, and then you can get the pump. But you're working inside of a fuel tank at that point. So again, these are centrifugal, which means they're high flow, but they're relatively low pressure. 20 psi, 40 psi. They don't need a ton of pressure. Their purpose is to move fuel from the storage location, collector tank, to the engine. Okay. The point that Corey was asking me, we were talking about collector tanks yesterday. So these would probably live in a collector tank. So it's trying to just make sure that the engines never run out of fuel, that there's always enough fuel going to them. It's not a high enough pressure to work the spray nozzles. When you get to your engine, there's going to be a high pressure pump on the engine itself. Okay? But in the tank, these boost pumps, all they're trying to do is move the fuel to the engine, move the fuel to another tank. If they're a scavenge type pump, move the fuel to the defuel system, move the fuel to the dump system, if that's the case. They can be installed in any of these areas. So used for engine feed, transfer, APU fuel feed. They can also be used for dump systems, defueling. Now, the other main type of pump we're going to see is an ejector pump or a motive flow or a venturi pump. And this one doesn't have any moving parts inside of it. But it does rely on, you need to have a fuel flow source, a fuel pressure flow source from somewhere else. So these are often used for scavenge as well as engine fuel feed. And you can see they got kind of this little like trumpet looking design going on. But here's a pump, and then here's the diagram of what's going on inside it right next to it, right below it. And so what's happening is we take a high pressure motive source and we shoot a little jet through a venturi, and then it's going to create a vacuum, a low pressure right here, that's going to pull a higher volume of fluid. So you take a high pressure, low volume jet of fuel, and you use it to pump a high volume, low pressure flow of fuel. And so, one way is for scavenge, where if there's like a low point in a center tank and you need to move that fuel to a wing tank, or a low point in the wing tank and get it into the collector tank, it can do that. They're often used out in the surge tanks, out in the wingtip, if fuel gets into that surge tank, to get it back into the wing tanks themselves. So there's usually a scavenge one at the bottom of your surge tanks out in the wingtips, if they have them. And then you can see where this outlet, this discharge, has a fuel line hooked up to it. In this case, I believe this one's an engine feed, but I can't remember for sure. Now this one, the fuel, the motive flow fuel, is coming in on the other side. There's a hole in this stiffener rib right here, and then it's sucking through. This is an open screen at the bottom that it's pulling fuel in and then running it up and out this hose to the right. Okay. So where do these get their motive flow fuel? Yeah. Okay. So you have to have motive flow fuel. You have to have this high pressure fuel. In some cases, they come from an electric pump somewhere else. Okay, you have a higher pressure electric pump. Okay. Oftentimes, what you'll have is, remember I said on the engine, you have a high pressure pump that's running fuel into the spray nozzles to actually spray a fuel mist into the engine. Often those have a line going back down to these as well. So the way these work is, where it's really slick is, you may have an electric boost pump that's kind of a backup or a secondary. You start that pump, you get your engine running. The engine-driven high-pressure pump, the pump that's on the engine is driven right off the gearbox. The engine's running, the high-pressure pump is running. That starts sending motive flow back to this, and that then becomes your pump that moves fuel from your tanks to your engine. And so as long as the engine's running, it's going to be self-feeding. The only way to shut that off is to close off the fuel flow to the engine so the engine stops running, so the motive flow fuel stops running. You have to have a valve that closes to cut off fuel flow to the engine. But as long as the engine's running, if the engine is that supplier of high pressure motive flow fuel, it will continue to supply the high volume of fuel needed to be moved from the tank to the engine. So kind of a quick diagram of that. If I have a fuel tank, here's my fuel tank. Here's my engine. Okay. I have one of these Venturi pumps in here. Okay. So this is our fuel feed to our engine. This is sucking fuel in from the tank. Once the engine's running, high pressure fuel from the engine pump goes here. So as long as the engine's running, it sends high pressure fuel here, that draws low pressure fuel in and continues to feed the engine. There's a second fuel line running back from the engine to supply the motive fuel pressure. Okay. So you have to get the engine started somehow. One is often these can be gravity fed, wings hang below the engines. Even if all the pumps fail, they're often going to be gravity fed as a backup. Or you have an electric boost pump. You have a second electric pump. Their electric pump that can also put fuel in. Okay, so you use the electric pump to get it started. Once it's started, the motive flow pump run. We had these on our airplanes. There was a day people got into this weird habit where, not habit, they were trying to see who could shut the airplane down the fastest. Pull up to the hangar, see who can shut the airplane down the fastest. Not a good thing to do, by the way. Think of it as a cautionary tale. You're supposed to use, we have checklists you're supposed to use. Plane comes up, taxis in, everything goes dark in it. So power's off, generators are off, lights are off, generators are off, lights are off, door opens, guys are standing at the top of the stairs. I'm standing there looking at the airplane, and they go, look at how fast we shut it down. And I said, that's wonderful, but your engines are still running. They never actually moved their throttles into cutoff. They never closed that fuel valve, and because it had this style, when the engine was still running, even though there was no electrical power, the engine still ran. It still was pumping fuel to it, and it was still running. So these don't care, again, if you have power. Okay? So these pumps then feed into the fuel distribution system. And roughly, I mentioned earlier that two common designs are a 3-tank and a 2-tank configuration. So we're just going to look real quick at each of those. So here's a 3-tank. Here's kind of a detailed schematic. These are scavenge ejectors right here. These are in the wings. Here are the collector tanks. Here's the center tank, but the collector tanks for the wings actually are inside of that. Fuel goes from those collector tanks down to the engine right here. Okay, so that's what's shown here. This is a very simple version of it. So engine fuel feed, collector tank feeds the engine. You can see that engine has fuel going back to the motive flow pump. And then there's a standby pump. Looks a lot like what I just drew right here, right? They're all illustrated here. So here is the main ejector pump that can feed the engine. Here's a left boost pump that can feed the engine. By the way, this is the type of aircraft that they left the engines running on. This is the fuel diagram from it. Okay. This ejector, the scavenge ejector, which is also powered, and here this blue going back is the fuel, the high pressure fuel from the engine, the little bit that's taken back for motive flow, gets sent back. It powers a scavenge ejector, which helps to move fuel from the wing to the collector tank. Gravity can also do that through this yellow line right here. And then some of the motive flow comes up to the main fuel pump right here, the main ejector, to send fuel to the engine. In this case, our center tank doesn't feed an engine directly. It has to transfer fuel out to either wing. So, excuse me. So that's shown Let me think. I haven't looked at. Yeah, shown right here. Sorry. You have a pump right here, APU pump that can move it out, and then fuel can be sent out to either wing tank. Oh, yeah. Okay. Little bigger diagrams of each of those. I guess this one would have been better to show. Okay. Differential pressure switches are there to make sure pumps are working. They tell you if the pump's working or not. Okay. In a two pump or a two tank engine or aircraft, you have this. The center tank's eliminated. The feed to the engines actually looks almost identical. So here's our engines, right? Fuel has to be fed to them. Fuel gets fed from, here's an AC motor pump. So here's your dividing line. Fuel from the left wing can come all the way down. This is essentially your collector tank right here. Okay, you see there's check valves. All these little red things are check valves. They allow fuel to go into this tank, but not out. AC motor pump can send fuel down to the engine, or the Venturi style pump can send fuel out to the engine. That Venturi pump is powered by the engine sending motive flow. And in this case, there are a couple of scavenge pumps throughout the wing. So you have one in this outer bay right here that can send fuel to the collector tank. You have one in the inner bay right here, also gets motive flow fuel from the engine. And then you have the actual Venturi main, there's one on the inboard bay right here, and then you have the main Venturi motive flow pump feeding the engines from the collector tank. Here's a block diagram version of it, maybe a little bit simpler. The main Venturi pump, AC motor pump, both of them can feed the engines. You also can open a cross feed to send fuel to either side, to both sides from one wing. The APU can also run off of, you can see in the right side, there's a DC motor pump that can feed in as well. That would be on to send fuel down to the APU during APU start from the right section of the manifold. So now we start to look at how these are displayed and controlled. What do we see up in the cockpit? Here is a modern ICAS display. So this is the same aircraft that you were looking at here and here. Okay. So with our normal thing, we have our tanks on the left and the right, and you can see these same fuel pumps are shown. Here's the AC pump on the left and the AC pump on the right that feed into for the left engine and the right with a cross feed. Here's that little DC pump that can supply the APU from the right side. A few of the things to show here. This is the multifunction display with our fuel synoptic on the left. We show fuel weights. These actually show an analog scale for how full the tank is too, by the way. You'll see a lot of, even with digital display, a lot of analog displays are still used. It's a lot easier to tell proportions as a human and how things are changing by looking at an analog display than it is to read a digital number that's changing. So here's our normal range, our cautionary range, and our you better get on the ground range, red, right? And these will change. You can see down here, when it's in the white, the normal, right? Everything's nice and green. And then you get into the cautionary range, and you can see it puts a big yellow box on our fuel level. And then we get down into the you better get on the ground warning range, and it turns that box red. Okay? Those would often be displayed with ICAS messages over here as well. On the main page, when you don't have this pulled up, the system page pulled up, here's the engine indication, and it just gives you fuel quantities, left, right, and total in this case. And again, if it gets too low, it turns yellow. And if it gets even lower, it turns red. Okay? So you look at the details. This whole system's controlled by a panel that looks like this. Here's that left AC pump. Here's that right AC pump. Here's that APU pump, DC pump. We can open and close our crossfeed. Or the Venturi pumps. Engine feed Venturi pump and scavenge Venturi pumps. Where are they? How do we turn them on and off? You turn the engine on and off, right? There's no control for them. So normally on this modern aircraft, these are kept in auto. If the Venturi pump is making pressure, these AC pumps will shut off. If the Venturi pump is not making pressure, the AC pumps will turn on. If you want to force them to turn on, you flip it to the on position. APU one, you put the APU, you reach up and put the APU into start, it automatically turns on that DC pump. You can turn it on manually if you need to. Crossfeed, it's off. You can, it's basically a check valve you can control. So say, you have low fuel on the left, you turn it to the left low, that's going to pull fuel from the right and send it to the left engine. Put them next to each other. There's that crossfeed valve with some check valve componentry to it. There's that left AC motor pump and our right AC motor pump and our DC pump. But again, no controls for the Venturi pumps. So let's see. I do have a video. If you have some time, I suggest taking a minute to watch it. I'm not going to show it right now, just in the interest of getting our stuff done. But it just shows it just shows the A320. They kind of walk through how the fuel system works on that, which is very similar to the couple aircraft that I showed up here. The two aircraft, the 3-tank aircraft was a CRJ. The 2-tank aircraft was an Embraer 175. So